So for this problem, the book asks you to identify which of these is the RR molecule, which one is the SS molecule, and which of these is a mesostructure. So mesostructure, as you know, is a molecule that contains two chirality centers, and they'll have a mirror plane in the middle which reflects one side on the other, and if one of them is an R, then the other one is an S. That is why they didn't give you an RS and an SR, because these two carbons have the same set of groups. So we just try to identify which among these structures is meso, which one is RR, and which one is SS. So I would like to first start with identifying which one of these structures is a mesostructure. So the best way to identify is stack one group in the front and try to align it with another group of the same kind in the back, and see if the other two group matches as well. So based on what I see here, I can see that this carboxylic acid is across carboxylic acid here. This is opposite to that hydroxy. Hydrogen is opposite to this hydrogen. So if I make a 180-degree rotation, this carboxyl will eclipse the carboxyl there. This hydrogen would eclipse the hydrogen here, and this hydroxy will eclipse the hydroxy there. So I'm just going to draw it to make sure you guys understand what I'm talking about. So if this carboxylic acid goes to the front, 180 degrees to the top, so that is the carboxylic acid in the front. This is the COOH in the back, and this hydrogen in the front, this comes to the front, and that's the hydrogen in the back, and this OH is going to eclipse the OH in the back. And this means that you have a mirror plane that is dividing the front carbon and the second carbon behind it, and therefore this is the mesostructure. So that's that. So this is meso. Now clearly the other two are not meso, because this carboxylic acid is across a carboxylic acid. This hydroxyl is not across a hydroxyl. This is also not across another hydroxyl on the back. Therefore, let's try to a wedge broken wedge notation of this molecule. So if you draw a wedge broken wedge, the carbon in the front has a so let's say you are standing here and watching that carbon. This carboxylic acid is below the carbon-carbon bond line, and here's your hydroxyl to your right, and here's the hydrogen to the left. That is the front carbon, and the carbon on the back is an inverted Y. So you have carboxylic acid here. To your right you will see the hydroxy, and to your left there will be a hydrogen. So as long as this carbon is concerned, that is priority 1, this will be priority 2, and this will be priority 3. This will be 2 because you have, so this carbon is essentially attached to 1, 2 and 3 oxygens, whereas this carbon is attached to 1 oxygen, 1 carbon and a hydrogen. Therefore this is priority 2. This will be 3. So fourth priority is pointed away. This is a 1, 2 and a 3. So that's an S configuration, counterclockwise like that. So if you now look at the other carbon, so this is priority 1, that is priority 2, and this carbon would be 3, and again it is counterclockwise. Therefore again this is an S molecule. So this is meso, this is an SS center containing molecule, and again if you draw this, it should be an RR, just making sure that we understand what's going on. I would do this here also. Carboxylic acid, hydrogen and OH. Carbon in the front, that's what that carbon is. Carbon in the back has carboxylic acid there, a hydrogen here, and an OH there. Priority 1, 2 and 3 counterclockwise, but hydrogen not in the front. So if you do the reorientation, you will see that this is going to be an R. So counterclockwise, hydrogen faced towards you, so that's an R. Same thing here, that is 1, that is 2, that is 3, counterclockwise but hydrogen projected towards you, or fourth priority projected towards you. That's going to be an R center as well.